Okay, so the thing to kind of picture in the back of your head when you're looking at this is essentially just a catalog. You might have a database, back end, which has, the title of your game that you want to sell, or we're selling games in this catalog, and, a small write-up about, what this game's about. And then, here you're displaying an image, which, this is just a JPEG in a database, for example, that we're pulling into our rich client application, and, we're texture mapping this on the front of a box. This box happens to look a lot like the Xbox game cases that you get when you order these games. Down here we have the rest of our inventory, and I mean this is the sort of thing that today when you go to the web and go buy things online, you normally see this sort of thing in like an HTML table. Well, the code here isn't much more complex. We have a data layer. It's importing our content. This can actually be a list box here. These are list items in the list box, and we've happened to have styled these list box items with viewport 3Ds, and where we're just taking a simple JPEG and just slapping it on the front of the same mesh. It's the same mesh for each one of these. Some other cool things about Avalon. When I click on this, you'll see a spin and transition effect. You'll see this, the currently selected game kind of swells up and becomes more prominent in your view. All these, this is the animation features and transition features that we have in our platform, being integrated all together to give you this much richer experience than you normally have today when you do your online shopping.
Right.
So that's that's largely our primary scenario is a better way to present 2D content. Another target that we're after is data visualization, and actually we've got another demo which is I think a good example of this, which it's actually an older demo. It's the blood sugar tracker demo, which was shown in the WinHack era. Let's press up a drink real quick. So here you have 4 patients, and they're hooked up to some sort of medical equipment that's reporting their blood sugar. And here you have a 3D bar graph, and we can hit this button and it'll actually pan around, so we can take we can see different aspects of the bar graph. We can actually click on the patients here and compare just the 2 that we're interested in. If we click on show patient details, we'll actually bring up more data about the patient, and you'll actually let me put this guy back in and take out these. You actually see that this is actually the same data shown twice. We have the same data behind, and we have 2 different views of the same data. So this is an example of the sort of things, kind of the sizzle and wow factor that we can bring to data visualization and business applications.
One thing I liked about this demo is you really show off the compositing engine in Avalon. I don't know if people can see, but you can see through to the 3D image through the 2D image, and then the 3D image composited back on. Can you speak a little bit about that and how hard that would be?
Well,
do you really get that for free here?
Well, where you typically see UI like this today is in video games. Video games will actually go and reinvent all of 2D to bring it into 3D and composite it like we're seeing here. They write their own button class. And since, Avalon, everything, even the 2D graphics, can end up being hardware accelerated through the 3D pipeline. The 3D graphics can fall back to software. Since we have one pipeline that we're dealing with here, we actually have this huge advantage when it comes to doing these composition effects, where you have alpha, where you see through a button into another pane into a viewport 3D. Like, to us, this is actually much easier to do.
It's kind of a side benefit of the Avalon platform. Right?
Yeah.
Excellent. Can you tell us a little bit about what it's like to program 3D? I know that's a vast topic. But
actually, I can give you an example really quick.
Okay,
Yeah.
so that would be excellent.
So I have Visual Studio installed, and I'll just, the really cool thing about the C2B drop is that we now have some tool support, and so here I can just create an Avalon application. And I'll just quick get rid of this grid that I'm not going to use, and hit Control F5, and we'll just see what we're starting out with here. So we've got an empty window, right? So
got it. Hey, do you want to pump up your font real quick so then people can see it better?
Yeah, I can try to do that.
Go to Tools.
Yeah, you might have to help me out. I don't.
Yeah, I've done this. Yeah. Options, fonts and colors.
So is that under text editor? Here we go. Got it.
And then just
pick a new size here.
Yeah.
Yeah, they don't let me do presentations that frequently, so I don't have all these tricks memorized. But so so we're going to display some 3D content. In order to do that, there are three key things that you want. First, you want a 2D rectangle where you're going to display your content. You need a 3D model, which unlike a 2D where the paradigm is usually, you draw the line where you want it, in 3D you actually make this model and then you put a camera in the scene looking at the model from the direction that you want to view it. So those are the other two things. You need a model and you need a camera. And we have a framework element, which is Viewport 3D, that brings all these together. The 2D rectangle aspect of it is kind of implicit. The Viewport 3D is actually run through the layout manager just like any other framework element. So you can put it in a grid and size it that way, or a flow panel, right? So that's where the rectangle comes from. We have to provide the camera, so we'll do that really quick. Let's see here. And we'll use a perspective camera. And we'll place it just a little bit back on the z-axis. And we have to tell it which direction is up. Say it's along the y-axis. And let's see what else we need. We need to look at a point. So I'll set this up so it's looking at the origin. And the last thing we need is a field of view, which is kind of the zoom. Well, pick 45, which is a little bit arbitrary. Okay, so we have a camera now. The other part of the scene that we need is the model that we want to look at. So yeah, models. Oh, one thing I left out is that because in 3D we have this lighting model, we also have to put a light in the scene. So
makes sense.
yeah, I was sticking ambient light in here. It's the easiest light to work with because it just lights the entire scene uniformly. And let's see here. We had a geometry model 3D. So what the geometry model 3D does is, Viewport 3D.models is this tree of model 3Ds. Some of the model 3Ds, like a light, light the scene. The geometry model 3D grabs a geometry 3D, which is a shape, and it grabs the material, which is how you want to paint that shape, and combines them together in a node. Materials are very, I'd say they're closely related to brushes in 2D, but because we have a lighting model, we have a more advanced class for that. But the material which I'll use is a brush material, which is really just an adapter back to what we're familiar with. So brush material, takes a brush, and I'll just say red.
Okay.
Okay, so we also need a shape, right? So model 3D geometry. And the shape that we're going to draw is a mesh geometry. And mesh geometry is an index triangle primitive. So the way this works is you define a set of points, then you define the order in which to connect those points to make triangles. So first we need our points, which are positions. Oops. Getting a little stage fright here and having trouble typing. But,
you're blowing me away here.
Okay, so 1, 0, 1, negative 1, 0, negative 1, 0, which is just it's just a flat square of no z dimension. I'm just using this because it's kind of easy to do at the top of your head. Normally you wouldn't define your mesh by typing numbers into a text editor. You'd use a 3D modeling tool, export that and load in just like you do images. You don't set the pixels with hex or anything like that.
Right.
So same thing here. So as I mentioned, you also need to define your triangle indices to connect these. So what I have right now are 4 points in space, and what I want to do is I say, okay, draw a triangle like this between our 0, 1, and 2. I think I did it this way. So I'll do 0, 1, 2, and then having drawn that, that's half of the square. Now I need to go 0, 2, 3, like that to draw the other half. And we'll hit Control F5, and after I fix up all my build breaks, which I'm sure are in here, we should see, oh, there's our first one. We should see that red rectangle. So viewport.camera, closing tag missing. Oh, it's Viewport 3D, okay. Let's see here, Viewport 3D.camera start tag. Yeah, I think it's the same error. Let's try again. Oh, got one more. The process is already running, okay. There we go. So there's our very simple 3D scene, which it doesn't look particularly 3D because we just have a square with the camera looking head on with an ambient light, so everything's uniformly shaded. So to kind of get the sense of 3D really quick here, let's not use a fixed camera position. Let's take a camera position out of this. And instead, since 3D is integrated with all the other features in the Avalon platform, we can use animation here. So we'll do perspective camera dot position, and then we can do a point 3D animation. Say this is from 005, which is where we had it before, and we'll do 2, 5.5.5. So it's kind of move to the right and up.
Okay.
And we'll say we want to do this in 2 seconds, so it'll take 2 seconds to make that transition. And we want to do that, you want to repeat, you want to do that forever. And after you've done it, we want to auto reverse. So I'll run that really quick. And now with the camera moving, you can kind of get a sense that this actually is 3D, and you can actually see the effects of foreshortening on this corner a bit as it transitions back. Let's just take a look really quick and see how many lines of code that was. So starting up here, so it's I've got 28 lines. So in 28 lines of code, we have an application which opens a window, which instantiates some 3D content, puts it into the scene, puts a light into the scene, creates a camera, and animates the camera. And I mean, all in XML, which is this wonderful declarative language, and just 30 lines of code. I mean, that's just incredibly cool.
And you can imagine if you were able to pull in primitives or meshes that were created by some other tool, then same amount of code, and you're going to be looking at something really great.
Yeah.
Very nice.
We could actually look at the Boing demo really quick if you wanted as an example.
Although actually, while we have some code here, it might be an interesting moment for you to speak to people a little bit about XAML and what XAML is here. And some people may look at this and love the idea that they get to write in markup, and other people may say, why are you making me use all these angle brackets? And well, it might help to, what's happening when this gets compiled, so to speak?
Okay, so first of all, we're not making you use angle brackets.
Okay.
Avalon and WinFX, bet big on managed code, which means that you can write against WinFX using any managed language, C#, VB, J#, and XAML is a new declarative programming language.
I see.
Being declarative, all you can do is instantiate objects and set properties on objects and wire them events handlers, essentially. You can actually put script blocks in XAML to handle those events, but those script blocks you actually write in a different language like C#.
Okay.
So
really, this is like calling a new window and then calling a new viewport 3D and setting a property, the camera property.
Exactly.
Got
it. I personally have grown to really love XAML because it saves me a lot of typing. You can imagine you do window W equals new window, button B equals new button, B dot content equals your text, and set all these properties on B. Then you do window dot content equals B, and that's how you parent it. You write all these lines of code. In XAML, so much this happens for you implicitly. Like the fact that the viewport element is underneath window means that this is the content of the window, and the parenting happens without me writing all this code.
Right.
Right. And,
so since you are a visual tree, it really makes sense for you to use this XML that's inherently hierarchical.
Right. Yeah. So it's a very good fit. And in cases where you have pieces of content that you want to share, the bowling ball actually is a good example because you've got the ball which you want to potentially want to show in 2 different places. You can actually make that a resource, which is a separate set of XML where you can define some global objects and then reference them from your main page and reuse them that way. Yeah.
Okay. That makes good sense. Well, let's take a look at Boing then.
Sure. I say sure, but I actually haven't opened it on this machine yet, so hopefully this is going to work. I think I've got it though. Okay. Let's make sure really quick that's running. Okay, yeah, so we've got it. So, this is the Boing sample, which, obviously it's much inspired by the, 1985 Amiga demo that was, so famous. Let's take a quick look at the code and, address the issue that you were just talking about. Windows and resources. I'm sorry, with XAML and resources. So here I actually have a huge blob of XML, and this is the the red and white checkered ball.
Uh,
The reason why it's so large is that at the time I was writing this, we were on the WinHeck build, and we didn't have everything hooked up correctly so that and you could use any type of brush. And so rather than texture map the ball, I actually created something like 128 little quads and pieced it together that way, which makes for very large XAML. So anyways, I have all of this here in a application resource, and the application resource has a name called ball. And then over here in my window, I actually have a viewport, and oh shoot, I didn't use it that way. That's right. I need to go back and fix this. So unfortunately, I didn't know how to reference a resource and put it into a collection. And Rob Relia, who is also another blogger, I pinged him really quick, and he came back with an answer immediately. It's simple, but I forgot to fix it. So unfortunately, what I'm doing right now is I'm actually loading the ball through application.current.resources. And so that XAML blob that we talked about is actually being parsed. Model 3D is being instantiated. It gets returned to me, and then I'm manually plugging into both viewports. But I can actually get rid of all of this code, and everything can be done purely through XAML, which I will do shortly. Now that I've embarrassed myself. So.
Well, the sample you have posted online now, is that
No, it's still this one.
good. Okay,
Yeah,
so-
unfortunately, I need to go
Well,
back
that's all
and fix
right.
that.
Well, maybe we can.
Yeah, this is actually the reason why the demo looks different in Chris Anderson's XAML pack clone, because he has only XAML and he couldn't do the multiple parenting through code. But now that we have the solution, we need to go back and fix that too. So.
Oh, I see. Okay. I mean, maybe we can get this timed so that you release the updated source when the video comes out.
Yeah. Yeah.
So.
Hopefully Rob's fix works, but I haven't tried it yet.
Okay.
So, anyways, so one kind of cool thing about the Boeing demo, at least that I thought was cool, is one, it showed that you can use XAML, not only as a markup format for declaring, user interfaces. Another purpose which we've discovered for it is it's now a 3D model format. It works just as well as a 3ds file or a .x file. Another cool thing about it is that, I was talking about the window resources, we can actually have one object and parent it multiple times. And so what we've done here is we actually have two viewports, stacked on top of each other, both of them looking at the exact same scene. And the animation of the ball rotating is actually shared between the two of them. That's actually in the XAML. We're using just purely the animation features of the platform in order to do this rotation with, the physics acceleration and everything,
Nice.
which is one thing that we couldn't do in WinHex. We didn't have animation hooked up for 3D quite right, but now that we have it, this is almost a no-code sample.
Wow.
What viewports? What are they? Why, you keep using that term.
So, actually, maybe I could grab a picture from my blog really quick to help illustrate. Let's see here. Oh, look at that autocomplete from my blog. It's not like I'm reading this at work. So, I have to go a little bit back in time.
By the way, if you're interested in Avalon 3D and you haven't read Daniel's blog, it is the place to go for 3D. He spends a lot of time writing really great posts.
Okay, so I was talking about how you need three things in order to display a scene. You need your 2D rectangle where you're going to paint the scene. You need your the model which you're going to display. You need the camera, and this little diagram here, I'm not sure how well it's going to pick up on video, is kind of, okay, so this is kind of, we have an axis out here kind of representing 3D space. You can imagine that, this is actually where the things join, but you can pretend it's a sphere in there. That represents your 3D model. And here you have this camera, which is viewing the scene, okay? At the front of your camera here, you have this plane, which is at a set distance from the position of the camera. So when I was hand coding this, I said, the camera is at 005. So you can imagine this is, 5 units back on the z-axis, looking towards the origin at, the content that we have there. And you can say, you've got a near plane of 1, and that defines a projection plane, which is, where the scene, this 3D scene, the part that you can see is actually going to be projected. So the viewport 3D is actually the framework level element that it provides the rectangle via layout services. So you put it in a grid, and the grid sizes it, and that's your rectangle where your 3D content's going to go. And then it holds onto a camera and the model 3D scene and combines those in order to give you the 2D representation of the 3D image.
So any 3D you want to do, you need a viewport. That's the foundation.
Yeah, that's generally a good guideline. You can actually go down to the visual layer and you know, manipulate things a little bit low level. When you go into the visual layer, you lose your layout services and you define the rectangle yourself. I'd say the 99% case is going to be viewport 3D.
Okay.
Yeah, it kind of exists mostly as an implementation detail for us to implement viewport 3D.
One of the things I've seen Avalon 3D use for is to put data on the sides of things, and that's really its strength, right? That you can do 3D and then you can bind data to the surfaces of your 3D object, right? And spin it around and make it bounce and do all sorts of stuff. Is that true?
Well, so is it true that you can data bind content on a viewport 3D? So there are ways that you can do that. For example, you can be pulling in your textures, you know, via data binding, and that way you can have, you know, content changing on your 3D surfaces. I kind of think the scenario that you're talking about is like I've seen, you know, webcasts where, or not webcasts, newscasts and such, where, you know, they've got breaking news and like the main person tilts away a little bit and it makes space on the screen for other content, and that's sort of, you know, kind of non-intrusive, subtle effect where you can, you know, shrink, you know, change the shape of things, turn things a little bit, you know, to create more surface area. I think that very much is, you know, what you'd use Avalon 3D for.
As somebody who's used to the 2D world, you know, using Visual Studio and such, you talked about viewports. Are there other concepts that I need to now concern myself with? Obviously, lighting is one, right? Mm-hmm. 3D space and shape. And
let me think about it. So what are the things that you need to know in order to use 3D? First, you need to discover the viewport element, which leads you to the concept of setting up a camera in 3 space and looking at a model in 3D and in 3 space. You have to somehow get that model. Unfortunately, right now, we don't have a solid story for how customers are going to import that. That's something that we're still very much looking at. We've heard lots of feedback that, you know, you need a content importation story. Not quite sure what it's going to look like. In the meantime, we're relying on people like Ian Griffin's happened to have written a DirectX, you know, .x file to XAML conversion tool, and I've been using that behind the scenes to make some of my demos happen. I know other people have been using it too. You know, a tool like that is how people are going to create their 3D content. But once they have the content, they still have to understand that they're working in a 3D space and, you know, position it, you know, in X, Y, and Z, which isn't you know, it's not a huge hurdle to get over. Just, you know, you spend some time with the whiteboard diagramming it. So the other things that you're going to need to know, you're going to need to understand lighting. The hardest part of lighting, I think, is normals. Understanding how normals affect, you know, what you end up with, you know, your shading on screen. Another aspect that you'll need to figure out is texture coordinates if you're doing, you know, if you're using more advanced brushes in solid color, which is you know, what I was demonstrating here, and how texture coordinates, you know, provide the mapping from, you know, your 3D space into the 2D texture that you're actually doing the mapping with. So those are probably the primary things you need to hit, and you know, a lot of that can be learned iteratively, which is nice. Mm-hmm. A lot of that is presented in an API, which is very much consistent with what you use in 2D, which I think helps the learning curve tremendously. And, you know, just the fact that, you know, Avalon 3D, you know, requires such little code to get you set up and running. You know, you don't stare at a blank screen and wonder why. You usually know what part of your code is causing it.